Welcome to my fundamental. Today we are going to do the integral of square root of 1 minus x squared from 0 to 1. And basically you can use the trigonometry substitution, let x is equal to sine theta and then keep doing. And you can also use the integration by part. But these methods are very basics, So today I'm going to use a really rare method. I don't think it's rare, but this really unpopular compared to this trigonometry substitution and then integration by part, So this is the way to do this. So I'm going to change the square root of 1 minus x squared to some for example, we are going to change it to our wheel of something, wheel part of something. The wheel part, imaginary part, comes from this formula. This is called the Euler's formula. E to the power of ix is equal to cosine x plus I sine x. So I'm going to somehow change the square root of 1 minus x squared into our RE of e to the power of ix, or the im of e to the power of some. I'm not sure what it is. So after we change it to something, we can put the re or im outside the integral. This is the properties of the integral, and then the re and im, they can switch. So second thing, be sure that function should. We want to somehow plus some functions, this x into this x, but be sure this function, it can be integrated as well. E to the power of ix, e to the power of negative x, they can be integrated, that's okay. But do you know what function you can integrate e to the power of something? Yeah, we have two functions like e to the power of inverse sine x and e to the power of inverse cos x, like that. So this function can be integrated, and even if in front it has a constant, they have a constant, they can also be integrated even if an indefinite integral. So I'm going to pick a random e to the power of inverse cos x. So I like to somehow put inverse cos x into it. E to the power of I times inverse cos x is equal to cosine of inverse cos x plus I times sine of our inverse cos x. So that's really easy. Cosine of inverse cos x is just equal to x. They cancel each other out. So what's sine of inverse cos x? So whenever you see a trigonometry function, inverse trigonometry function that's inside the trigonometry function, we need to use the let theta or y is equal to that. This is the angle, inverse cosine of something. So I decide to use theta. Or we can use y, up to you. So cosine of theta is equal to x. So cosine of theta is equal to x over 1, right? So we can draw the triangle right now, right triangle, put up theta, and then cosine theta is equal to this, x over 1, right? X over 1. And then this length is just equal to 1 minus x squared, right? Because of the Pythagorean theorems, this is a right triangle. So here's the deal. E to the power of I times inverse cos x is equal to x plus I times, and then consider this sine theta, right? Sine theta, and then sine theta is just equal to square root of 1 minus x squared over 1. So far you pretty much just get I times square root of 1 minus x squared. So you can compare the both sides. A real part of the e to the power of I times inverse cos x, and this cannot be simplified anymore, I think. The real part of this is equal to x, and then the imaginary part of square root of it should be e to the power of I times inverse cos x is equal to square root of 1 minus x squared. X is just the real part, and then square root of 1 minus x squared is just the imaginary part, you know. So we can change this square root of 1 minus x squared into our im right now. So you know what I say, the RE and IM you can put it outside the integral. So because this square root of 1 minus x squared is equal to that. So let me just put them IM outside the integral of this e to the power of I times inverse cos x dx. So as I mentioned before, e to the power of some constant times inverse cosine, they can be integrated, you know. So to do this, let me use the substitution. Let u is equal to I times inverse cos x. So we're gonna divide by I on both sides. Divided by I on both sides. Here's the deal. U over I. To simplify, I don't like the I on the bottom. I like to be on the top. So multiply by I on both the denominator and the numerator. So you get I times I is equal to -1. So over you get negative IU. So after you divide by I on both sides, you get negative IU, and then take a cosine on both sides. So cosine of negative IU will be equal to x. So because cosine is an even function, you can change it into cosine of our IU, right? It's equal to x. And here's the fun part. Cosine of IU, this is equal to our cos u. Hyperbolic cosine of u is equal to x. Because the reason why this is the form, cosine x is actually have the form. It's come from the Euler's formula. Well, as Euler's formula help us a lot, you know. So cosine x is equal to e to the power of ix minus e to the power of negative ix over, it should be positive, plus. So whenever we plug ix into it, you get e to the power of I times I plus e to the power of negative I times ix. It should be ix divided by 2. So for I times I is -1. So you pretty much just get e to the power of negative x plus I times I is -1. In front we have a negative side, so over you get e to the power of x over 2. And here's the deal. This form, e to the x plus e to the power of negative x over 2. The order really doesn't really matter. The order doesn't really this American English is kind of hard, you know. This is just the hyperbolic cos x, hyperbolic cos x. You can pronounce this as cos x, so I decided to pronounce this as cos x. So we are going to differentiate both sides. You get, however though, you know the derivative of the original cosine of u is equal to negative sine u, but cos is really different compared to cosine. So the derivative of cos, you should remember this is equal to our positive sinh u du, and this is just equal to dx. Derivative of x is just dx. So let me just change it into here. So let me just don't care about limit first. So e to the power of I times inverse cosine x, you get u, and then you should multiply sinh u du. So we are going to figure out what's the lower limit and upper limits, because we are already in our u world, so we don't need to let u is equal to the subject. Just put number inside, and then put 0. And inverse cosine is kind of, I think you guys see it really weirdly, right? You always see inverse x more, right? So here's the deal. Whenever you put 0 into it, think about cosine of what angle will give you 0? Yes, this is pi over 2, positive pi over 2. But in front, we are going to multiply by I. Like that. And then this one, put 1 into it. Inverse cosine of 1. So cosine of what angle will give you 1? So this is 0. So the angle should be between 0 and pi over 2, be sure. So here's the deal. E to the power of u times sinh. You cannot use the integration by part, as I mentioned before on my previous video. Because whenever you use the integration by part, differentiate, we want this integral to get a repeating situation, right? So differentiate this 2 times. Differentiate this sinh x. Differentiate this once again, you get positive cos x. Differentiate this, you get positive sinh x once again. So you get positive. So the original integral and that repeating integral, they cancel each other out. So don't do that. So I pi times 2, I would like to change it into our L and I. You know, L and I is equal to I times pi over 2. So let me change it to L and I. L and I, this is really, really cool. Right? The integral of this going from L and I to 0. So since u, it actually have the form, you know, this is e to the power of u minus e to the power of negative u divided by 2. And then parentheses times du. So we can put the 1/2 outside. So Im of 1/2 is just 1/2 times Im. They are the same. Im of this L and I 0. And then we're gonna distribute inside. At the power you get e to the power of 2u. And then e to the u times e to the power of negative u, pretty much just get 1. So over you get negative 1 du. So here's the deal. You get 1/2 times Lm, 1/2 times Ln of. Integrate this, you get e to the power of 2u, and then divided by then what's 1/2. So integrate 1 in our u, you get u, and then we're gonna evaluate from L and I to 0. Be sure this Lm is just this entire thing. So after we are going to put it inside. So let me do it. Let me just write down my parentheses here. Sorry, my fault. Plus 0 into it. E to the power of 0 is just 1. In front we have a 1/2, so over 1/2. Plus 0 into it, so minus 0, and then you're gonna minus this. Plus 0 into it. You will get, it should be L and I, sorry. L and I. So minus 1/2 times e to the power of 2 times L and I. And then minus become positive, so you get positive L and I. So overall, you get 1/2 times Im of 1/2. 0 doesn't matter. Here's the deal. You can put the 2 inside the Ln because of the power properties, right? The Ln properties. So put the 2 inside. That E and Ln, they will cancel each other out. So you pretty much just get I squared. I squared is what? I squared. You pretty much just get -1, right? -1 times -1/2, you pretty much just get positive 1/2. And the L9, as I mentioned before, this is equal to pi over 2 times I. So 1/2 plus 1/2 is just equal to 1. And then plus our pi over 2 I. Yes. Finally, we are going to find the imaginary part of 1 plus pi over 2 I. So our real part is just 1, right? imaginary part is just pi over 2. So let me put down this is equal to 1/2 times pi over 2. So overall, your answers will becomes positive pi over 4. And this is really really cool, you know. But I spent 15 minutes on this video. This kind of hard. If I don't show this, the explanation about this, it might takes me only 10 minutes or 30 minutes. I don't know. But I think if you want to make a questions yourself, and the question should say integrate this from 0 to 1, and you cannot use integration by part and then substitution. And then you can use substitution and then integration by part, you get pi over 4 as well. So you can do it by your own, and you can also choose. You can also plug e to the power of I times inverse x. I think that's you can do the same like this. So do it on your own. Yes.